Table 690.7 of the National Electrical Code addresses maximum system voltage considerations. To determine the maximum system voltage, a multiplier is applied based on the lowest expected ambient temperature. The multiplier for the next temperature higher on Table 690.7 is 1.17. For example, if the lowest temperature in your application is 15 degrees Celsius, the maximum system voltage can be calculated as follows. Maximum system voltage equals 600 volts times 1.17, which equals 702 volts. This calculation is an approximation, and the actual maximum system voltage can vary based on the specific equipment and materials used. It is crucial to consult the manufacturer's specifications for accurate information on voltage limits and temperature coefficients. Understanding how temperature affects voltage is essential for safe and efficient system design. Lower temperatures increase voltage output in photovoltaic systems, and the NEC requires that these increases be accounted for to prevent overvoltage conditions. Using the multiplier from Table 690.7 is a simplified way to ensure that the system voltage remains within safe limits under all operating conditions. The table provides multipliers for various temperature ranges, allowing for adjustments based on the expected climate and installation location. Always verify the specific temperature range for your installation site and use the corresponding multiplier from Table 690.7. Additionally, it's important to note that other factors can also influence system voltage, such as irradiance levels and the specific characteristics of the photovoltaic modules being used. These factors should be considered in conjunction with the temperature correction to determine the overall maximum system voltage. Consulting with a qualified electrical engineer or solar installer is recommended to ensure accurate calculations and compliance with all applicable codes and standards. Failing to account for temperature-related voltage increases can lead to equipment damage, system failures, and even safety hazards. Therefore, it's imperative to perform thorough calculations and implement appropriate overvoltage protection measures. The NEC provides guidance on overcurrent protection and surge protection devices that can help mitigate the risks associated with high voltage conditions. These devices should be selected and installed in accordance with the manufacturer's instructions and the requirements of the NEC. In addition to temperature corrections, it's also important to consider voltage drop in the wiring and conductors of the photovoltaic system. Voltage drop can reduce the overall efficiency of the system and may also affect the performance of connected equipment. The NEC provides guidelines on conductor sizing to minimize voltage drop and ensure that the system operates within acceptable voltage limits. Proper conductor sizing is essential for both safety and performance, and it should be carefully considered during the design phase. Furthermore, it's important to regularly inspect and maintain the photovoltaic system to identify any potential issues that could affect voltage levels. Loose connections, damaged wiring, and degraded components can all contribute to voltage fluctuations and system inefficiencies. Regular maintenance can help prevent these issues and ensure that the system operates safely and reliably over its lifespan. When performing any work on a photovoltaic system, it's essential to follow all applicable safety procedures and, where appropriate, personal protective equipment. Working with electricity can be hazardous, and it's important to take precautions to prevent electric shock and other injuries. Always energize the system before performing any maintenance or repairs, and verify that the system is properly grounded. The NEC provides detailed requirements for grounding and bonding photovoltaic systems, and these requirements must be followed to ensure electrical safety. In summary, calculating the maximum system voltage in accordance with NEC Table 690.7 is a critical step in the design and installation of photovoltaic systems. Temperature corrections, voltage drop considerations, and overvoltage protection measures are all important factors to consider. By following the guidelines of the NEC and consulting with qualified professionals, you can ensure that your photovoltaic system operates safely, efficiently, and reliably. Remember that this is an approximate calculation, and the actual maximum system voltage may vary depending on the specific equipment and materials used. Always consult the manufacturer's specifications for the most accurate information. This information is for educational purposes only and should not be considered a substitute for professional engineering advice. Always consult with a qualified engineer or electrician before making any decisions about your electrical system. The National Electrical Code, or NEC, is a comprehensive set of standards that governs the safe installation of electrical wiring and equipment. It's updated every 3 years to reflect the latest advancements in technology and best practices. Adherence to the NEC is essential for ensuring the safety of people and property. Understanding the NEC can be complex, but it's crucial for anyone involved in the design, installation, or maintenance of electrical systems. The code covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It also includes specific requirements for different types of electrical systems, such as photovoltaic systems, generators, and emergency power systems. To stay up to date on the latest changes to the NEC, it's recommended to take continuing education courses and consult with qualified electrical professionals. The NEC is a living document that is constantly evolving to address new challenges and opportunities in the electrical industry. By staying informed and following the code, you can help ensure the safety and reliability of electrical systems. Furthermore, it's important to understand the difference between the NEC and local electrical codes. While the NEC provides a national standard, local jurisdictions may have their own codes and regulations that are more stringent. It's essential to comply with both the NEC and all applicable local codes when installing or modifying electrical systems. Local codes may address specific issues that are unique to the area, such as weather conditions, soil types, or building construction practices. By following both the NEC and local codes, you can ensure that your electrical system is safe and compliant with all applicable regulations. In addition to code compliance, it's also important to consider best practices for electrical system design and installation. This includes using high-quality materials, following manufacturer's instructions, and performing thorough inspections to ensure that the system is installed correctly. Best practices can help improve the reliability, efficiency, and longevity of the electrical system. They can also help prevent problems that could lead to safety hazards or equipment failures. Consulting with experienced electrical professionals can provide valuable insights into best practices for electrical system design and installation. Their expertise can help you avoid common mistakes and ensure that your system is built to last. Regular maintenance is also essential for ensuring the long-term performance and safety of electrical systems. This includes inspecting wiring, connections, and equipment for signs of wear, damage, or corrosion. It also includes testing overcurrent protection devices and grounding systems to ensure that they are functioning properly. Regular maintenance can help identify and address potential problems before they become major issues. It can also help extend the lifespan of electrical equipment and prevent costly repairs. Developing a comprehensive maintenance plan is crucial for ensuring the reliability and safety of electrical systems. The plan should include regular inspections, testing, and maintenance procedures. It should also include documentation of all maintenance activities. By following a well-defined maintenance plan, you can help keep your electrical system in top condition and prevent potential problems. Finally, it's important to remember that electrical safety is everyone's responsibility. Whether you're a homeowner, a business owner, or an electrical professional, you have a role to play in ensuring the safety of electrical systems. This includes following all applicable codes and regulations, using safe work practices, and reporting any potential hazards. By working together, we can help prevent electrical accidents and injuries. Educating yourself and others about electrical safety is a crucial step in promoting a safer environment. This includes learning about the hazards of electricity, how to prevent electrical shocks, and how to respond to electrical emergencies. It also includes teaching children about electrical safety and ensuring that they understand the importance of staying away from electrical hazards. By raising awareness about electrical safety, we can help reduce the risk of electrical accidents and injuries. Understanding the fundamentals of electrical theory is essential for anyone working with electrical systems. This includes understanding voltage, current, resistance, and power. It also includes understanding the relationship between these quantities as described by Ohm's law. Ohm's law states that voltage is equal to current times resistance, which can be written as volts equals amps times ohms. Understanding Ohm's law is crucial for calculating voltage drop, determining conductor size, and troubleshooting electrical circuits. In addition to Ohm's law, it's also important to understand the concepts of series and parallel circuits. In a series circuit, the current is the same through all components, while the voltage is divided among the components. In a parallel circuit, the voltage is the same across all components, while the current is divided among the components. Understanding series and parallel circuits is essential for analyzing and troubleshooting electrical circuits. It's also important to understand the difference between alternating current, or AC, and direct current, or DC. AC is the type of current used in most homes and businesses, while DC is the type of current used in batteries and electronic devices. AC current changes direction periodically, while DC current flows in one direction only. Understanding the characteristics of AC and DC current is essential for working with different types of electrical systems. Furthermore, it's important to understand the concept of grounding. Grounding is the process of connecting electrical equipment to the earth, which provides a path for fault current to flow back to the source. Grounding helps to prevent electrical shocks and reduce the risk of fire. The NEC provides detailed requirements for grounding electrical systems, and these requirements must be followed to ensure electrical safety. Another important concept to understand is overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from excessive current. When the current exceeds the rating of the overcurrent protection device, it will trip or blow, interrupting the flow of current. Overcurrent protection is essential for preventing damage to electrical equipment and reducing the risk of fire. The NEC provides guidelines on selecting and installing overcurrent protection devices, and these guidelines must be followed to ensure electrical safety. In addition to these fundamental concepts, it's also important to stay up to date on the latest advancements in electrical technology. This includes learning about new wiring methods, energy-efficient lighting, and smart home automation systems. The electrical industry is constantly evolving, and it's essential to stay informed to remain competitive and provide the best possible service to your customers. Continuing education courses, industry conferences, and trade publications are valuable resources for staying up to date on the latest trends and technologies. Remember that working with electricity can be dangerous, and it's essential to follow all safety precautions. Always de-energize electrical circuits before working on them, and wear appropriate personal protective equipment such as insulated gloves and safety glasses. If you're not comfortable working with electricity, it's best to hire a qualified electrician to do the work for you. Electrical safety should always be your top priority. Remember that this information is for educational purposes only and should not be considered a substitute for professional engineering advice. Always consult with a qualified engineer or electrician before making any decisions about your electrical system. Consulting the equipment manufacturer's specifications provides the most accurate information regarding the device's functionality.